Hello, myself Vishnu Prasadkar. I am going to speak about structure and bonding as decided by the International Institute of Information Technology Bhubaneswar for its selection of faculties. As the topic defines structure and bonding, it says how structure relates to bonding and how bonding relates to the structure. This we can take in three parts. One is the structural pattern, which is responsible for the bonding of atoms, and this bonding of atoms further says is different structures possible of the different a large number of groups such as crystals and molecules. Again, let's go to the structure of atom. Structure of atom. Before going to structure of atom, what is an atom? Atom is the smallest particle of element, and it contains electrons, neutrons and protons, which have been found by different experiments. Among these particles, proton and neutron resides in the center of the atom, and electrons is outside of the nucleus. Among these, if you see, the Niels Bohr has proposed one atomic theory. According to this theory, electron is circulating in certain permitted circular orbits, which are also the energy levels surrounding the nucleus. With these electrons, when residing in one particular orbit, it will never gain energy and lose energy. But if you want to go to the higher energy level or go to the lower energy level, then it has to absorb energy in form of radiation or lose energy in form of radiation. And also, this theory also says that these circular orbits are quantized. This quantization defines by the angular momentum. The angular momentum of the electron is integral multiple of h by 2 pi, where h is the Planck's constant. Bohr's theory could able to explain so many factors about like such as hydrogen atom spectrum, but it could not explain a lot of other matters also, such as the dual nature of the electron. That is, it could able to explain the particle nature, but it could not explain the wave nature of the electron, and also it could not help to follow the Heisenberg-Sonnenstein's principle, which says position and momentum cannot measure simultaneously. It has also another loophole is that it could able to explain the systems with one electron, but not with multiple electrons. Whereas quantum mechanical approach could able to solve the problem. According to the many quantum mechanical approach, Schrödinger's approach is familiar to the chemists. According to Schrödinger's approach, we have to solve the Schrödinger equation to get the system, to get the understanding of atom. The Schrödinger equation says H psi is equal to H psi, where H is one of the operator, psi is the wave function of the system, and E is the energy, and again psi. So when we solve this equation for the polar coordinates of an atom, we can come up to points about orbital. Orbital are the nothing but these are the three-dimensional space surrounding around the nucleus, which is basically the probability of finding an electron is maximum at those spaces. So there are four types of orbitals possible: S, P, D and F. And these S, P, D, F orbitals further classified in different orientations in space, such as S is spherical, while P is dumbbell shape, but it has three orientations along x-axis, z-axis and y-axis. So they are different to Px, Py, Pz. And again, the dz orbitals are like double dumbbell shapes. They are all 5 in nature. And F orbitals are little more complicated structures, which are of 7. The energy levels, the orientations, which are different orientation in particular one orbital type, are degenerate. Means all orbitals are of equal energy, so they are called degenerate. Px, Py and Pz are of equal energy. These are called degenerate orbitals. Further, quantum mechanics approach gives different quantum numbers. These are to identify one electron in an atom. First is the principal quantum number. It says about the cell in which it says about the cell around the nucleus in which electrons resides, and they are numbered as 1, 2, 3, 4, 5, 6, 7 according to the increase of energy. They are also numerically alphabetically says K, L, M, N, O, P, Q. And again, then let's go to the azimuthal quantum number, the second quantum number, which tell about the subcells inside one cell. And these are like numerically represented as 0, 1, 2, 3 and alphabetically S, P, D, F. The number of subcells is equal to the number with which the cell is represented. That is, if the cell number 1 will have 1 subcell, cell number 2 will have 2 subcells, cell number 3 will have 3 subcells. Similarly, next we will go to the third quantum number, that is called magnetic quantum number, M. This is says about the orientation of orbitals in space. That is, here how many quantum numbers are possible? That is 2l plus 1 number of quantum numbers possible for one subcell. As we have represented here 0. If you put 0 here instead of L, then we can get 1. That means S subcell can contain 1 orbital, 1 magnetic quantum number. When it is 1, it is 3. When it is 2, it is 5. When it is 3, it is 7. Again, next quantum number is spin quantum number. This says how an electron spins. It can have only 2 spin states, half and minus half. Pauli's principle decides how many electrons can reside in one magnetic quantum number. That is, only 2 spin states possible for one magnetic quantum number. That is, it also in a broader sense we can say 2 electrons in an atom cannot have 4 quantum numbers alike. Based on this principle, we can say for other quantum numbers how many electrons can reside in these according to the quantum numbers. That is, for magnetic quantum number there can be 2 electrons, 1 pair electron. That is 1 pair of electron. When we go to the subcells, it can have 2 into 12 plus 1 number of electrons. And when we go to the cells, it will have 2n square number of electrons. Let's go to the building of electrons in an atom. It is defined by the Auer principle. Auer principle says when an electron goes to the atom to reside in cells, subcells and orbitals, it will go to the first lowest energy state, then it will lowest energy level, then it will go to the higher energy level and higher energy level and higher energy level. By this point, the electron first goes to the 1s orbital. If the 1s orbital is filled, then it will go to the 2s orbital, then it will go to 2p orbital, then 3s orbital, as it is shown in here. That means we could able to say how the electrons will arrange in subcells. But then again, as we understood that some subcells like P will have 3 orientations, then how electron will be arranged in these orbitals? Let's see. Wundt rule says if there are degenerate orbitals of equal energy, then all energies should have first 1 electron each. That is, let's take the case of the example. Some examples like boron, 1:2:2 P1. Here, electron 1 electron will go to the 1p orbital. But when it comes to carbon, it will have 2p orbitals, 2 electrons in p orbitals, p cells, p subcell. That means this electron will go to the second p orbital. It will not go to the same first p orbital where it has 1 electron. It will not be paired up. It will be single electron to come here. Similarly, when we go to the nitrogen, there will be 3p electrons, and all these 3p electrons will be arranged singly in all 3p orbitals. But when we go to the oxygen, now the pairing starts. 2 electrons will be in the first, other 2 will have 1 and 1. So that means when electrons will be filled in first this orbital, then this orbital, then pairing starts. Then we will go to see how the bonding occurs. This is the structure of atoms we have seen. Now we'll see what is the bonding. Bonding is basically, it is a tendency of of the unpaired electrons to be paired. That means when we see the first before slides is that many atoms will have unpaired electrons. Then these unpaired electrons have a tendency to be paired up. This pairing will lead to decrease in the energy of the system. That means stability. This gives the two atoms or more atoms to be combined together to form bonds. In this way, what happens? If the one point is here is that if the electrons are paired, that is almost like it is the 8 electrons in its valence shell, then those atoms will never combine, such as helium, neon and argon. A chemical bond can be defined as force of attraction between atoms by which they are held together. And we will be discussing here two main types of bonds. One is ionic bond and covalent bond, and two other types of bonds are there which we will be discussing in the later stage. Ionic bond is basically where the one or more electron leaves the orbital of one atom, that is called donor, and paired with another electron in the orbital of another atom, that is called acceptor. In this point of view, this donor atom will be positively charged and this acceptor atom will be negatively charged. The energy needed to remove one electron from the donor atom is called the ionization energy, where the energy released when an electron goes and resides one of the orbital of the acceptor atom is called the electron affinity. But yes, and after the formation of the charged particles like cation and anion, there will be a interaction of the interaction between the opposite charges. That is basically the force of attraction between these opposite charged ions is known as the ionic bond. And due to this attraction of the cations and anions, there will be a lot of energy liberated. This energy is called lattice energy, and the ionic bond should be stable if the lattice energy is greater than the combination of the energies like ionization energy and electron affinity. Let's see some example. Take the case of the example of lithium chloride. Lithium will have 3 electrons and its valence shell will have 1 electron. And fluorine 9 will have 9 electrons, and it has p orbital will have 5 electrons. In this case, you will see this 1 electron will go to the p orbital, will be loosed by the lithium atom and will remove the electron and form lithium charge, while the 2s becomes 0. And then similarly, when fluorine atom will take the electron and will become the negative charge. Now 2p will have 6 electrons. So this is positive charge, this is negative charge. There will be interaction between the two and they will form the lithium chloride. We will see some lattice energy like lithium chloride will have energy almost like 1046 kilojoule per mole. A very strong bond. And few others are there also. Now we will go to the characteristics of ionic bond. How the ionic bond will be. Okay, the ionic bond leads to mostly some crystalline solids. This is the first point I want to be emphasis on this as we will go on ahead. They are also hard and rigid, highly dense, high melting point, boiling point, highly brittle. They conduct electricity in solution and molten state. Ionic bond, this is another important point I want to discuss, is that ionic bond is non-directional. That means if the positive charge is there, it have a uniform field around it. And in this case, the negative charge can come from any direction of the positive charge. That's why it is called non-directional. That is, which I have pointed out here also in this structure. Then, the point I was telling you about, the important point, the crystals. This is we are going to discuss structure of crystal. Basically, ionic compounds forms crystalline solids. Basically, ionic compounds are the crystalline solids. How it is the case? It is because although the ionic bonds are non-directional, but a particular ion will surround by some particular opposite charge ions. This is decided by the size of the ion. and this leads to an order arrangement of the ions. And that's why these are called crystalline solids. And this lead to a particular structure of crystals, unit structure of crystals, and this structure will also be responsible for due to the radius. That's why here I want to point out that a particular crystal structures and for ionic compounds, it depends on the radius ratio of the cation and anion. Here I have shown some radius ratio, and this is according to the radius ratio. As goes on increasing, the shape changes, as we can observe here. We can see one example is like cesium chloride will have a cubic structure where cesium resides in the center of the cube and chlorides are on the vertices. And here sodium chloride, it will have a octahedral structure, and where each atom will be arranged in a phase center with cubic manner. So there is a perfect structural properties for crystals. Now we will go to the covalent bond. Where covalent bond is a properties where is a bond where the electrons from different atoms pair together, but both the atoms will share the same electron. It is little different from the ionic bond, because ionic bond the pairing takes place in one particular atom, but here it is different. That means both will act as donor and acceptor. In few cases, a number of atoms share the electron pair is more. Let's say the next point is that sharing of electrons forces the atom to combine to form covalent bond. That means this nucleus of the two atoms will attract the same lone pair, same electron pair. That's why they will not leave each other. Based on the molecular orbital theory, in the covalent bond, the atomic orbitals combine together to form molecular orbitals. Covalent bonds are mainly two types, sigma